So today we are going to talk about the probability function. We're going to introduce it officially and formally. I know you are familiar with the concepts of probability since, I don't know, third grade, when the teacher talks about more likely, less likely, improbable, or never happens, or will happen for certain. And of course, you've been seeing probability even in this course with the normal distribution. But today, what are we going to do is we're going to focus on the details because everything matters. An or is different from and, a parenthesis is different from brackets, an event is different from a real number. So pay close attention because every particular notation is telling you a unique story. And if you mess up the notation, the story is might look to you the same, but it's actually going to tell a different story, which is something you don't want to happen. So pay close attention, even though some of these concepts will be very easy for you. First, the probability function is just a function. And what it means is you have an input and you have an output. So I'll put it in red. So let's say I have a function called f of x equals 4x. Okay, I have an input, let's call it I, and I have an output, call it O, and I have a function that maps, sorry, my F looks bad, it maps the input to the output. So if my input is 0, the image will be 0. If the input is 1, it'll send 1 to 4, and if it's negative 2, it'll send it to negative 8. Make sense? Notice that the input is just a bunch of real numbers, and the output is also a bunch of real numbers. That's what this particular linear function does. The probability function is also a function in a sense that it has an input and it has an output, and that's your function, P. The difference, though, is the input is an event. So you always start with the event as your input. Whatever goes inside your parentheses, P of x, right? That is your event. And usually it is written in plain English, but we have shortcuts or a shorthand notation, mathematical notation that actually refers to the English statement. Okay, so feel free to say it in English or in mathematical terms. And the output is a real number, except that this real number has to be between 0 and 1. So for instance, if you flip a coin, the probability of getting a tail, I didn't want to write getting a tail, I just wrote a tail. You know what I mean. The probability of getting a tail is 1/2. I'm assuming the coin is fair, which means both the head and the tail have an equal chance of showing up. And let's say you roll a die, okay, which has 6 faces. And this means the probability that you roll a 4. The top face is a 4. Well, if the die is fair or unloaded, that probability is 1/6 because there are 6 options. Okay, let me pause here and talk about fairness and unloaded in case you wonder what I'm talking about here. So here is my die. Okay, this is my die, and it's labeled 1 through 6. Generally, the center of gravity, let's call it G. Sometimes we give it a name called centroid. You've seen it in physics, maybe. G is the center of gravity, and it is equidistant from this face and that face. It is also equidistant from this face and that face. And the same thing, it is of equal distance from the back side to the front side. There are ways, and I'm not going to get into it, but there are ways for people to change the center of gravity G, and so let's say make it there. Well, if the center of gravity is the green G, then it is more likely that this face, or maybe the back face, or maybe the side face here, are more likely to happen, as opposed to this one and that one and the front page, right? The back, the bottom, and the fronts, and this side, right? That's why we use the word fair or unloaded. And we're always going to make that assumption, okay? So let's go back here. So the probability of getting a 4 is 1/6. What's the probability of rolling a 2 and a 5? Notice and here, it's not an or. And notice that this is an event. You roll a 2 and you roll a 5. That is an event. Well, clearly you cannot get a 2 and a 5 at the same time when you roll a die once. So that probability is 0 or 100%, 0%. This and is called a conjunction, and it's so different from the or. What's the probability that you're watching this video or listening to this video? Well, you are listening to me right now. So that probability is 1 or 100%. So I gave you two examples where you have the extreme situations because the real value that you get is between 0 and 1 inclusive. It is possible to get 0 or 1. So I gave you two extremes and I gave you two actual numbers, okay? Now, for this function to be a probability function, not only that the input is an event and the output is a real number between 0 and 1, it has to fulfill two conditions for it to be called a legitimate probability function. For it to be legitimate, so this is not legitimate, for instance. If I say to you, probability that something happens is 5, and you say, well, this is not legitimate. Why? Because this number is not between 0 and 1. So these are the conditions. The probability of any event x has to be between 0 and 1 inclusive. It is the equal sign, okay? That's the first condition. The second condition, the sum of all the probabilities has to be 1. This is just a shorthand for P1 plus P2 plus P3 all the way to Pn. If you add them up, you must get 1. If you don't get 1, it is not a legitimate probability function. This x here, which I referred back here and here, notice it is a random variable, and in our case, it is a discrete random variable. In fact, x only takes the values 1, 2, 3, 4, 5, and 6, right? Because you're rolling a die. Sometimes it's continuous, like in the normal distribution we discussed before. So let's introduce it formally now. So let's say we roll a fair die, fair, okay? And let's x stand for, let's x stand, not stands. Sorry. Let's x stand for the digit that you roll. The very first thing you should always do is to write your sample space. Your sample space is the set of all possible values. Well, if you roll a die, there are 6 possible values, right? So you just list them. Okay? So if I ask what's the probability of rolling a 2, that's 1/6. There is only one option out of 6 options. What's the probability of rolling a 1 or a 5? Well, to roll a 1, you get 1/6 chance, and to roll a 5, you get 1/6 chance. Notice that I just added those two probabilities. This is called a disjunction, not a conjunction, so you've got to be careful. If this was an and, the answer would be 0, wouldn't it? You can't get a 1 and a 5. And or, usually or translates into an addition. But be careful, I'm going to come back to this, okay? Notice within the event, you can have the word or. You don't want to have a plus here, that's silly. And the same thing here, you cannot have an or. This is a number, isn't it? Probability of an event is a number. Since this is a number and this is a number, you can only add them and multiply them and subtract them. You're not going to have the word or here or and or something silly. Okay? I'm going to come back to this one, even though it should make a lot of sense to you. I'm going to come back to it. It's kind of misleading, okay? So what's the probability of receiving a 2 and a 4? Well, that's 0. We just discussed it. What's the probability of not getting a 2? Well, you could do it two ways. You could approach it the direct way. Not getting a 2 means getting a 1 or a 3 or a 5 or a 4 or a 6. Sorry, I flip-flopped 4 and 5. Which is a 6 plus a 6 plus a 6 plus a 6 plus a 6, which is 5/6. Or You could do the following. The probability of not getting a 2 is 1 or 100% minus the probability of actually getting a 2. I am utilizing what we call the complements, the concepts of complements, which I'll address in a second. Now we know that to get a 2, there is a 1/6 chance, and 1 minus 1/6 is the 5/6 that I just received earlier. Let me pause here for a second and talk about complements. So if I have a set A, its complement is usually labeled as AC. Sometimes you see this, something like this, right? But in general, we use A with little c. And it's not the opposites. The complement means the leftover. So let's say I have my sample space here. This is my sample space. This is the whole thing, okay? And let's say this is A in blue. This is A. A complement will be the stuff in green. It's just a leftover. In such a way that if you add set A to A complement, this is how we add sets, union. This is how we add sets. You actually get the sample space. In fact, if you intersect A with A complement, you should get 0, or the empty sets, right? They don't intersect. They never intersect. A and A complements, they don't intersect, but they complement each other. They complement each other. And I'm going to pause here for a second because a lot of people think they think the world works in a binary situation. Let's say I say A is yes. What's A complement? Freeze the video and think about what is your A complement. How many of you wrote no? Okay, that's false. Okay, so A complement means the complement of yes, which is not yes. Okay, so you might argue with me, isn't not yes no? Not necessarily. In the future, in your whenever you have just two outcomes, you know, on, off, things like this, yes. So probably if it's not on, it's off, right? But generally, there is so much gray area. There is so much gray area in the middle. And the complement of this in blue is not this in red, because you also have to account for the gray area. So, for example, in your math courses in the future, some advanced math course, you will talk about sets. You'll talk about open sets. And there are sets that are actually open. Some of them are closed sets. Some of them are both open and closed, and some of them are neither open nor closed. So if I say to you, what's the complement of open sets? Don't say closed. What about these two? Okay, that would be your complements. If this is A, this would be your A complements. Okay, so be careful. What's the complement of no? What's the complement of no? Don't say yes. Just say not no. Make sense? All right. So let's go back here. So this idea of complements is really useful because sometimes you don't want to take the direct form. P of x equals 1 plus P of x equals 3 plus P of x equals 4 plus P of x equals 5 plus P of x equals 6. It takes forever. Taking the back roots is a quicker way to do it. For instance, let's say I have 16 students in the class, and one day two students show up. Do you think it would be wise of me to sit there and take a roll and start calling people by their names, 16 of them, and waste time? Silly. It would be actually easier to focus on who is present and then just figure out who is absent, right? Now, if 19 of you are present, I may want to take a roll to figure out who is absent. But if only 2 of you are in class, it makes no sense for me to take attendance in that sense. Start calling people by their name and not hearing from 18 people or 14 people. All right, so the probability of A complement is 1 minus the probability, sorry, the probability of A is 1 minus the probability of A complements. The converse is true, because by the way, the complements of A takes you back to A, right? You can also maneuver this. You can move this stuff here, and you can move this stuff here. You get this for free, right? So the probability of A complements is 1 minus the probability of A. Or you could also say this. Probability of A plus the probability of A complements. I've never written this. Equals 1, right? Right? So that actually summarizes both of them. Okay, so the last thing I want to talk about is this idea of OR, which I addressed here briefly. So pay attention. If I say to you that the probability of A or B, and in here we said it's the probability of A plus the probability of B, and we were correct for a good reason. This is not always true. In this case, it is true. Let me visualize it for you. So let's say this is A and this is B. These are your two sets, and they intersect here, A and B, okay? And the probability that A happens is the blue stuff, and the probability that B happens is the green stuff. So if I say to you, the probability of A or B is the probability of A plus the probability of B, if I stop right there, as I did here, what's going to happen is if I add this area, watch what I'm doing here. If I add this area to this area, do you see that I counted the intersection twice? So I'll do it again. So watch the intersection, okay? So I count the area. I just went through it. I just went through this piece, right? And then I'm going to add this area, and I just went through this piece again, right? So we've got to take it away once. This is a true statement. This is always true. You never have to argue with anyone. You can always take this for granted. You could put it in your pocket and use it anytime you want. Now, if there is no intersection whatsoever, let's say A and B look like this. There is no intersection. The intersection is the empty set. They don't intersect. We call them disjoints. We call them mutually exclusive. We say A intersects B is the empty sets. All of these things that I just mentioned can be used interchangeably. If that is true, then this is this plus this minus nothing, because the probability of A and B is 0. There is no intersection. And that's why I only added the two pieces. I didn't subtract the intersection, because there is no intersection. Let me put it this way. Let's play dumb. Let's do P of X equals 1 or X equals 5. And let's use the actual formula, which is always true. Okay? So I will get P of X equals 1 plus P of X equals 5 minus P of X equals 1 and 5. Now, clearly, as we did before, this is 0. You cannot get 1 and 5 at the same time when you roll a die once. And hence, you only get this, which is what I wrote here, which is this shortcut. If there is no intersection, P of A or B is just the sum of these two. The problem with all of this, my friends, is a lot of kids think this is always true. It's false. This is not always true. This is always true. So I'll put it in big black. True. Always. You can use this anytime you want. This is true under this condition. Okay? So think of this as a rectangle, and this is a square. If you start with a rectangle, you might get a square for free. If you think the whole world works with squares, you may never think of what is a rectangle. Okay? A square is a special case of a rectangle. You can use this anytime you want. You can use this, which is this piece up to here, only if the events are disjoint, mutually exclusive, have no intersection. A intersects B is the empty set. Call it whatever you want. So that should end this video. Take care.